Welding is the process of melting metal materials with heat and joining metal workpieces together. It's a key technology that supports the manufacturing industry. But that's just the basic definition. In fact, there are many different methods used in welding. There are entirely manual methods, such as shielded metal arc welding and TIG, tungsten inert gas welding. There are semi-automatic methods that automate the task of feeding the filler material, such as MAG, metal active gas, and MIG, metal inert gas welding. Then there are fully automatic methods, such as submerged arc welding and robotic welding. The range is quite extensive. Among these, CO2 gas arc welding is a welding method that's come to be used in a wide range of industrial situations, adopted for its superb work efficiency. This is a semi-automatic welding method that uses coiled metal wire as the electrode and filler material with manual torch operation. In CO2 gas arc welding, the wire itself is the electrode, generating an arc between itself and the workpiece. This is the molten weld pool that forms as the workpiece metal and wire melt. When it cools and hardens, it becomes the weld metal. During welding, CO2 gas is sprayed continuously, providing a shield so that the weld metal is not oxidized and nitrided. First, let's look at this comparison of welding speed between CO2 gas arc welding and shielded metal arc welding. As you can see, CO2 gas arc welding is much faster than shielded metal arc welding. But that's not all. The arc is well converged and penetrates deeply into the workpiece. Little slag is generated. There's a low quantity of hydrogen in the welding metal, so the weld offers high crack resistance and good mechanical properties. Its high work efficiency and economical operation are other special features. The only drawback is poor operation in the wind, so for outdoor work, where the wind is blowing at 2 meters per second, 4.5 kilometers per hour or more, it's necessary to set up a screen or other windbreak. Let's take a look at the welding equipment. The CO2 gas arc welding equipment consists of a CO2 gas cylinder, welding power source, wire feeder, remote control box and welding torch. The welding power source is a direct current power supply unit that features a constant voltage, constant speed feeding system. It supplies the current for generating the arc that melts the wire. This is the control circuitry built into the unit. The wire feeder. This apparatus uses a motor drive to feed wire continuously to the welding torch at a constant speed. The torch. Although this work is performed manually, the welder doesn't have to replace the electrode each time, as with shielded metal arc welding. Plus, having a high current flow to a thin wire significantly improves work efficiency. Two types of wire are used. One is solid wire, comprised of metal alone. The other is flux cored wire, which has a core of flux inside the wire. In addition, there are different types of wires that are used according to the type of base metal or welding conditions. In this video, JIS Z3312 YGW12 1.2 mm wire is being used. This is the apparatus for supplying shielding gas to the weld zone. This video image, shot using a special technique, shows the shielding gas as it comes out of the nozzle. The shielding gas prevents the weld zone from being oxidized and nitrided as the wire is fed into the active electric arc, forming the weld pool. Every job begins with a safety check. First, the welder puts on protective gear. This protective gear not only ensures the welder's safety, it's essential for allowing him to concentrate on the job. Next is the equipment and tool check. Make sure that the connection to the welding machine is secure, that nothing is wrong with the cable connection, that no part of the torch is damaged, that the nozzle and contact tip aren't loose. And that the orifice is in place. These pre-welding preparations and checks tend to be neglected, but you should always perform them to prevent accidents and to ensure welding quality. After the safety checks, hold the spool like this and check the wire to make sure it has no rust or dirt. Then connect the spool to the welding machine. Feed the wire into the groove of the feed roller. Then press the inching button to feed the wire into the torch. Next, adjust the welding settings. Settings are determined by the diameter of the wire used, the type of base metal, plate thickness, shape of the joint, welding position, and so on. Begin with the shielding gas flow rate setting. The gas flow rate is shown by the position of the ball inside the flow meter. Here, a flow rate of 20 litres per minute is used. The welding current and arc voltage are set using the current and voltage dials on the remote control box. First, let's look at the use of a welding current of 200 amperes and an arc voltage of 24 volts. Next, let's see a high current welding arc used for welding heavy plates. The welding current is 280 amperes and the arc voltage is 30 volts. The arc feels different and there's much more spatter. Take account of the wire extension. The wire should extend about 15 millimeters when using a 200 ampere welding current. What kind of changes occur with different wire extension? If the wire extension is too long, a drop in the welding current causes lack of fusion and degradation of the shielding capability, which can result in blowholes or other defects. If the wire extension is too short, the current increases, which overheats the tip, causing the wire to fuse to the tip and for spatter to accumulate on the nozzle, ruining the shielding. So when the wire extension is too long or too short, you can see that it affects the welding results. Be careful to keep the wire extension always at the appropriate length. When the wire extension has been determined, ignite the arc to see if the welding settings made earlier work properly. After performing this check, use a scrap plate, strike the arc over it, and determine from the arc if the settings are appropriate. For this test, hold the torch at an angle of 10 to 30 degrees so that you can see the arc clearly. It's also important to keep the wire extension at the same length as you will use for the actual welding. If the arc voltage is correct, check visually that the weld pool moves in tandem with the wire when the wire tip is moved. There should be little spatter, with the arc sounding like this. You can check the suitability of the arc voltage by observing the arc length. If the arc voltage is too low, the arc will be shorter and the wire tip will dip into the weld pool. In extreme cases, the wire tip will hit the bottom of the weld pool, creating a popping sound, and the impact will be felt in the torch. The arc may also cut out, or the short wire will melt and splash out. In contrast, if the arc voltage is too high, the arc will be longer, become unstable, and be unable to easily reach the desired position. There will also be more spatter and less penetration. Keep a close eye on the arc, listen to its sound, and adjust the voltage accordingly. Next, recheck the welding current. Check the ammeter to see if it's operating at the set value. If not, adjust the welding current and also recheck the arc voltage. This is how it should look. Practice over and over again, keeping in mind what the correct arc should be until you have a clear image in your head. This indicates the proper range for welding settings. As the welding current rises, so does the arc voltage. You must establish the appropriate settings if you want to obtain good welding quality. After this series of preparations is finished, try welding. First, face the workpiece and adopt the correct posture for working. Practice moving the torch several times from the start position to the finish position to be sure that you can move without interference. Until you become well practiced, it's fine to hold the torch in two hands. If there is no problem, set the wire tip at the start position for the welding. Press the torch switch. The arc between the wire and workpiece will then strike. The wire and workpiece will melt and a weld pool will form. When the weld pool spreads and becomes stable, start moving the torch. One method of operating the torch is to move it in a straight line while keeping the wire extension length even. This is the stringer method. Another is to move the torch back and forth in a zigzag pattern in the forward direction. This is the weaving method. There are two additional methods that depend on how the torch is tilted, the push and draw methods. With the forward push method, the torch is held at a 10 to 30 degree angle as it's pushed forward. With the backward draw method, the torch is also held at a 10 to 30 degree angle, but it's drawn backward. With CO2 gas arc welding, for easier viewing of the bead formation and the welding line, as well as to get the best shielding from the gas, the forward push method is most commonly used. What you see here is the stringer method using a forward push. If you are right-handed, it's most common to proceed from right to left. With the forward push method, the penetration is shallow and it's easy to produce a flat bead. This is the weaving method using a backward draw. It offers deep penetration, making it easy to produce a bead with a sufficient degree of reinforcement. When operating the torch during welding, it's important to keep the torch at a fixed angle and height. Because it's entirely handheld, the torch might become tilted or shift up and down without your being aware of it. If this occurs, it will cause fluctuations in the bead profile and give rise to defects, so be sure to stay alert. The quality of the weld varies significantly depending on the skill of the welder. Please review the results of your work to find any place where you made a mistake or did a poor job. In this way, you'll develop proper workmanship.